Hi, hello, CogX. How are you enjoying this Festival of the Future? My name is Roeland. I'm the founder and CEO of Decorte Future Industries, and my company builds novel artificial intelligence to extract health data from sound. Now, this year's CogX theme is how do we get the next 10 years right? But hidden in that theme, implicit in that theme, is the question, what direction do we set for the next 100 years of tech? Because the reality is that the direction that we set at this early stage, especially for AI, will have long-term implications. It's easy to forget just how fast things can move after a major technological shift like the one we're currently experiencing. There are only 66 years between the invention of the first airplane and the moon landing. 66 years between the first heavier-than-air flight and us conquering not just air, but the atmosphere and Earth itself to reach for the stars. So it's difficult to underestimate just how transformative AI will be over a similar 66-year period. Now, it's naive to assume that as we're all embarking upon this journey together, we'll get it right the first time. We'll need to have the courage to consistently reconfigure and constantly question ourselves and the direction in which we're building. It's easy to get swept away by the status quo, by the current tech, or at least the current manifestations of it, and let it lead us rather than the other way around. And in that way, we actually forget what we're building for. So that's true for us as a society, but it's especially true for a high-growth business, and that's what I'm talking about here today, is I'm going to take you through the journey of my company, hopefully as an illustration that the greatest power a founder or a company can have is the ability to consistently and continuously question themselves and reconfigure themselves. And that means accepting uncertainty, not ignoring it, and taking the reins despite of it. It means listening to the data that the market is sending you, listening to the data that your R&D is sending you, even if it seems to question all your strongest held beliefs. It means engaging in data-driven pivots, which is what the talk is about. Now, my father was born with a congenital heart disease. There was a hole in the upper chambers of his heart, and essentially what would happen is blood would flow through from one chamber in the heart to the other. This wasn't picked up on for about 38, 39 years. Either his parents had been told at his birth and it had been observed, but they never told him, or they had just never seen it. Either way, he lived with it for 38, 39 years until he would have, and I was 11 at the time, he used to have these moments of extreme distress. He would not know what these were coming from, but he had an inkling that it might be his heart, so he went to the doctor. Now, the doctor listened to his heart for about 10 seconds and said, all is fine, just go, you're okay. He went to another doctor a couple of weeks later. They said, listen to his heart for about 10 seconds, said, all is fine, you're good to go, just go. Ultimately, it was my mother who insisted, no, we're paying for a proper kind of, a proper thorough look at all kind of aspects of your physiology, and we're going to pay for a private clinic to do that, that they discovered, oh God, you have this very serious condition. We need to have you in open heart surgery as quick as possible. Now, I still remember to this day that my father put this floppy disk on the mantelpiece. Why a floppy disk? I don't know. I'm pretty sure we had USB drives at the time. Maybe just like to be retro. But on that floppy disk was a letter from my father to me, my mother, and my brother in case he would make it. Now, he made it. He did essentially have to quit his job. He did, and to this day, he is still dealing with the complications of it, but at least he's alive. Now, the clincher in all of this, the main takeaway, is that had anyone listened to his heart for longer than about 30 seconds during the whole 39 years of his life, they would have picked this up. But no one ever did, because our healthcare is punctuated. It's not preventative or predictive, it is only curative. Now, I have a rather unconventional background. I first went to Cambridge when I was about 15, joined some lectures. Then at 16, I got the scholarship. At 17, I started living full-time in the colleges. And I did my undergraduate master's and then ultimately PhD in a very weird subject, which is ancient code breaking, where I used modern cryptographic methods and modern mathematics to decipher ancient codes. However, whilst I was writing up that PhD, this problem, this thing that had happened to me when I was 11, continued to kind of live rent-free in my mind. And I thought, surely it can't be this hard. Surely there's just lots of different sensors. We know an ECG sensor, we know an IMU sensor, we know temperature sensors. You can easily get them off the shelf. attach them to the human body, upload that data with Bluetooth low energy into the cloud, done, right? Solution. Why has no one built this? Obviously, I began building it and very quickly realized why no one was building it. And the main reason for that was that you need continuous skin contact. If you have to have sensors on the human body, it has to be on something that you're continuously wearing. Generally, the only thing for us, that's clothing. Now, integrating sensors into clothing, one of the things I really quickly discovered is none of our clothing actually fits us that well. And there's not enough continuous skin contact to be able to accurately upload data into the cloud for it to be kind of on a medical level. So the next problem we had to solve was fairly simple. Solve the problem of fit. So I started building a rather complicated metal contraption, later called an exoskeleton, that allowed any piece of clothing to fit any human body size or shape. You basically pushed a button and it went zip. I started building this. This took about 1.5 years, 2 years to then integrate the sensor array. And it was around this time also that the MOD started hearing that I was building this. They got quite interested. Ultimately, long story short, they endorsed us. The UK Army endorsed us. DARSA wanted to invest. And I was at this stage where I realized, this is really cool. I have a company here, but I've not achieved what I set out to achieve. My father would never have worn a military Spec Ops exoskeleton. So back to the drawing board, I thought, and I didn't accept kind of the DARSA funding, and essentially what at that time I did, and this was just when my company, we were selected for Techstars 2020. At the time, I said my company was essentially just still a one-man band, just me. But then I hired my absolutely excellent and brilliant CTO, Erica Bonda-Riva, and we started essentially trying to create an in-between version, a less complicated version of this exoskeleton. Now, at that time, in international media, there had been multiple articles about apps being developed by the University of Cambridge, MIT, and a couple of other universities, specifically to detect COVID using only your voice. By essentially you coughed into a phone and it would tell you whether or not you had COVID. It would diagnose that. When I first heard that, I thought, I don't quite believe that, because I've just built these really quite complex exoskeletons, knowing how high the bar is to get to a level of diagnosis. So I really need to know about this tech. And Erica was actually one of the people who was building this tech at the university. Now, very quickly, I realized that, yes, as always, it was slightly exaggerated in the media in the sense that it couldn't diagnose yet. It wasn't at that level, and there were some flaws, like if you came from Italy, you were thought to have had COVID, because at that time, most people who were in Italy had COVID. So if you spoke Italian, that was sort of dooming you in that app. But there was very clear potential there. And one of the things that I thought of, one of the things that we kind of realized is actually if we use a sound-based solution in exoskeletons, instead of actually using the proper full metal side to replace those sensor arrays, sound would be a perfect match because it allows no skin contact, and actually even more revolutionary, sound is just a single sensor that can do lots of different metrics. So instead of focus on COVID, we went to focus on heart and cardiovascular. So went to focus on respiratory. We went to focus on things like even mental health, or actually we can even do blood kind of glucose monitoring. But that's a story for another time. Now, whilst we were building that, the idea was, okay, we will build an in-between version between our exoskeleton and this sound-based as non-invasive as possible solution. And that was Mark 1, who's with me here on stage today. I had to drag him all the way. So this is an in-between solution between our current one and the past one. I had to drag him all the way on the underground, which was a bit of a pain. There was one person who asked me, so what's in that? And I said, oh, it's a prototype exoskeleton. He's like, yeah, whatever, and walked off. Like, okay. But essentially, Mark 1, we deployed in care homes and in the care sector. And we had customers who were willing to pay for it. We were able to deploy it. But very quickly, one of the things that we realized was that everyone wanted to deploy it in their own way. And all the larger companies we were talking to, all the tech giants and so forth, they wanted to use just the tech. They weren't interested in the shirt. And it was around this time also that I realized actually what the data is telling me here is either I really focus on one market, which is the care market, and we limit ourselves to that, but then will I again have achieved my mission? Because my father would then only ever have been picked up on once he ended up in a care facility. And will that also allow us to have the market size and the company size that we actually were hoping for? Now, that's when we decided, and here's some of that evolution, that's when we decided that actually the best approach to this is not to offer customers a Sainsbury's ready meal of essentially an end-to-end solution where we package it in a very specific way, but instead to let the customers themselves decide how they wanted to deploy this kind of revolutionary new technology. And that was essentially what we ended up doing, is building an engine where anyone can send sound in and we extract health data out from that sound. Obviously, depending on where the microphone is in relation to the body, we can do different types of metrics. But that was essentially one of the main changes, the latest primary big pivot that we did, is where we went from essentially hardware company to an AI first and purely AI company, where we would license our tech to third parties. Now, as soon as we did that, things kind of exploded. So we got lots of different partnerships that, some of which I'll announce tonight. We had lots of the tech giants reach out to us. In the end, we ended up with 2 of Microsoft's execs on our board. And I'm extremely happy to announce today, for the first time publicly, that we have 3 new key partnerships. One, which is we are working with Google to integrate into Android. Second is we are exploring with Microsoft integrating into their AI systems, such as ChatGPT. And third, we have partnered with Apollo Hospitals, which is one of the largest healthcare providers in the world, for massive clinical testing in order to validate this and ultimately, together in partnership with also some US-based clinics, go for FDA approval. Now, throughout this journey, there were 2 main moments, really, where all the forces working upon us were telling us to stick in the lane that we were, to basically go in the direction that we were going. The first was after graduating Techstars, when we had also already just turned down the DASA funding, we were offered a VC investment. But the problem was, at that time, we weren't certain yet that we actually knew what the final solution was going to be to our problem. We weren't sure what exactly the solution would look like. We just had built this and we were testing it, but I didn't feel we were ready to scale. Had I accepted money at that time, the VC likely would have and wanted metrics, and we likely would have a company right now, which is a defense-based exoskeleton company. Now, that would have been fine, but we would not have achieved the mission we set out to achieve. Similarly, and that second point, when we were at the stage where we were deploying it in care, we had customers who wanted to pay. It all seemed like a good company. But again, I had to go back to the mission and realize, actually, the data is telling me that if we really want to have the impact that we set out to have, we cannot limit ourselves in this way using hardware for one specific subsection of that market. So as a founder, generally what will happen is your friends and family, your investors, your mentors, and especially your team will always favor the status quo. It's generally up to you as a founder to make sure that you don't become arrogant, that you don't start thinking, I know what the direction forward is, because you don't. That's the definition when we're doing something really new. Because once you become too arrogant, you stop listening to the data that's coming from the R&D and the data that's coming from the market, then you are losing out on the opportunities. It sounds very strange, but actually the best way to avoid mission drift is often to pivot. And not pivoting, like it happened with me 2 times, would lead to mission drift. Now, I started with the fact that the theme of CogX is how do we get the next 10 years right? There's a sad and slightly dark thing implied and part of that as well, which is that not all of us are going to be here 10 years from now. In fact, there's a lot of people in this room over 35, and 1 in 3 of everyone over 35 in the next couple of decades will die of a cardiovascular disease, likely a preventable one. But not if my company succeeds in its mission. That is our hope, that is our aim at DFI. And whilst it sounds grand, that is genuinely what we want to keep as our North Star. And I think it is companies that prioritize their mission over the manner of their execution, the method of their execution. I think that that is the secret for a successful startup to really thrive. That was me. Thank you very much.
Thank you very much, Roeland. That was a fascinating chat. I have some questions for you. So you have talked about some wonderful announcements today about the future of your company and some partnerships and some plans that you're hoping to do to take your technology and embed it and expand it into different use cases. So first, as a potential recipient of this technology, is there an element of consent? So if sound can indicate my health status, what happens if a tech company or some other company that I'm interacting with that is just simply using your technology could know things about my health that I myself don't know and that I haven't consented for them to discover about me? How does that work on the ethical question for you?
It's one of the biggest kind of ethical concerns, and one of the reasons why from the very beginning of the company we want to make sure that we set a very kind of clear ethical framework of how we do this, because otherwise you can very clearly see the kind of use case where someone puts a phone in the middle of a table during an interview and they figure out that you have some kind of condition that you actually didn't legally have to disclose to them, and then they make a decision on the basis of that. So the actual use of our tech kind of only should happen, and we can very clearly kind of obviously legally ramify that and kind of so I can navigate that by saying it must only happen in these kind of circumstances when there is mutual consent, but obviously some people can use it for bad. And that's why the way in which we're actually doing it is we're not allowing a licensee or a third party to be able to access our black box and get things out. They would have to send all the data, they would have to have an agreement with us, send all the data directly through us, and then only then will we be able to kind of send metrics back to them, which means that generally we will only be dealing with very large corporations, and if they break the law by doing something like this, of course, then we can go after them for that.
So there would never be a risk of this, for instance, being embedded in like an Amazon Echo that people are keeping in their houses and in their shops and in their companies, and then you could be like, oh, I went over to have dinner with my friends Bob and Jane, and they discovered that I have Parkinson's, and I didn't know that myself.
100%. So actually embedding in things like Amazon Echo or Google Assistant is exactly some of the things that we are looking at. But one of the advantages, one of the things that can keep you safe here is that the actual, as I said at one point in the talk, the distance of the microphone to your body also creates a natural barrier. So only with your consent will you place a microphone actually on your body, which is when we can do complex cardiovascular and other analysis. If it is just you're in the house and you're walking around and they're analyzing your mood using an existing kind of AI, that you can already do today, sadly. So I think for us that big barrier is the proximity of the microphone to your body. So yes, there will always be chances for abuse, but it is quite, it's quite limited.
So at the moment, the best way for this technology to work is for it to be as close to your physical self as possible. So you would probably know and hopefully be consenting to this.
Hopefully, yes. So and if not, then there's something seriously wrong, right? But there's metrics we can pick up away from the body, but that is similar to metrics that are already currently being gathered, like, for example, voice data, using that for mood analysis, or, the cuff detection and things like that. So there is potential for abuse, yes, and that's one of also the reasons, one of the earliest things we wanted to do was set up this ethical framework, and we started talking with Dr. Julian Huppert, who used to be the MP for Cambridge, to kind of make sure that we have this external robust framework of how we internally at least use it. But down the line, one of the things we don't want to do is it to fall into the hands of, say, for example, hostile governments who then use it to monitor their citizens. There's potential of abuse, as with, I think, any application of AI, but also potential to do great good.
What about for things like health insurance companies in the United States that will sometimes deny people coverage and leave you with a medical and financial emergency? How would you make sure that not everyone gets to live in a country with socialized medicine? How would you do that so that...
Two things for that. One, for health insurance, one of the things that actually insurers are often happy to pay for is things that are predictive or preventative, because it means that their costs at the end are a lot lower, are a lot less. So they actually have a vested commercial interest in trying to find out what's wrong with you as swiftly as possible, which also will help you because of the fact that you will then not develop this disease further unnoticed. When it comes to them, for example, it's a bit like that black box that you can have when you're driving a car, where you can have, and I do foresee a future where technology, or potentially my technology, is used in a sense where you can sign up for wearing this device, and as a result, say, for example, the costs of your premium will be lower because they can monitor you on the go. But that, again, would need to be entirely on the basis of consent.
But is it really consent? Because if you can't afford healthcare, and the only way to get cheaper healthcare is to agree to be surveyed in this really quite detailed way, is it really consent?
Well, the current way in which it happens is you have to go to a doctor of the actual insurance agent, and you have no clue who that person is. You have not chosen that individual. They can ask a range of questions, and they don't actually disclose that data to you afterwards. So at the moment, and similarly also when you said with the punctuated element, at the moment, in order to have anything close to continuous monitoring, you would have to either be extremely rich, like you say, where you would have to go into the doctor and you even have a personal physician, like they call them, custodian physicians and so forth, and then you'd be followed up on. Our technology is the first time that you actually put that in the hands of everyone, because the costs of a microphone is negligible. In fact, everyone here in the audience at the moment has a microphone in their pocket. So in many ways, what we're actually doing, multiple ones, in many ways, what we're actually doing is we're democratizing, we're allowing access to this kind of predictive and preventative healthcare that normally the vast majority of us now wouldn't have access to. In fact, the partnership we have with Apollo Hospitals, we're working specifically in rural areas of India where people normally don't have access to clinics whatsoever, in order for this to essentially allow that first stage of triage to happen. So I think, yes, you can say there's an extent to which, if, as with anything that is commercial, you will limit things if someone has to pay for it. But the reality is, if now the bar in order to pay for it is so high, and we lower it all the way down to make it accessible to almost everyone, then I think we are doing the opposite thing of what you were describing.
And I'm intrigued, is there any relationship between this decoding of the body, which is the work you're doing now, and your doctorate research in decoding ancient languages?
It's all pattern recognition. And I think that's true for most things. It's true for running a company as well. It's essentially trying to figure out from a huge mass of data, those little elements that you think are significant, then running them through patterns, trying to find recurring patterns. And that is true with data-driven pivoting. It's true for AI. It's true for ancient code breaking. I think a lot of kind of that thinking is the same. So in many ways, the answer is no, but in, I think, the fundamental way, in a way that most matters, yes, that's kind of how I got there.
So if you had to decipher health, you're going through sound at the moment. Do you have other venues of R&D that you're contemplating? So it's not just going to be sound, it could be other ways of reading the body.
So there's existing startups. Say, for example, there's an Israeli startup that does video-based analysis of your face. And for example, if you start sweating, they put that in hospital rooms so that if a patient starts sweating, they know that they have a certain type of condition, and they do heat maps and so forth. The answer for us is no, though, because the unique thing about sound is, as I said, it's one sensor multi-metric. But also unique about sound is the fact that it's so low cost. But if we can, as we are now currently doing, have a microphone in everyone's hands, and it's one sensor multi-metric, we can actually even reuse existing audio that we've previously recorded to add new metrics. And in many ways, what we can continuously keep doing, if the person, again, decides to do that, they can, over time, we can expand the types of metrics that we look at. So at the moment, it's cardiovascular, we're doing respiratory, doing coughing, but you can also look and listen to abdominal sounds and figure out whether someone has stomach cancer. You can do things like use voice analysis, which already so many companies are doing, and add in kind of mental health detection. There's so many. In fact, we have a list of about 45 metrics that we know that we still want to build out, that there's no point for us to ever change modalities, because the exact strength of the company, the reason why I wanted to make sure that we scaled and not just stayed within a single sector, is because it is that one sensor, one modality, multi-metric kind of solution.
Does this change at all as the human body ages? Do our sounds change as we age?
Of course, yeah. Everything about the human body, sort of, as we age, has a slightly different physiology, will result in lots of different kind of reactions, how things kind of, how you look and also how you sound.
That's amazing.
Yeah.
Do you have any limits? Like, have you tested on babies at all?
So actually, neonatal, there's academic studies that have done that. That sort of, some of them are being done by our current CTO, but in her academic role. There's a lot of, I'm personally really excited about kind of prenatal and neonatal care. I think that is one of the best applications for our technology. We've looked at essentially the end of life cycle, but I think the beginning of life is one of the, and also even for things like fertility, a lot of people who struggle with fertility will have to measure their temperatures every morning. They will have to kind of continuously keep track of their physiology. But this essentially allows them to do that, to do that for them. And here's again where, when we say kind of, is it to some extent creepy that Alexa would be listening to us. Well, it's just like Google is listening to me now when I say, hey, Google, so that it can respond. If you consent to it, one of the things we could do is, if we indeed integrate into your existing home devices this kind of monitoring, it might be a lot easier for you in your fertility monitoring to be able to just say, use your Alexa or use your Android phone to do all of these things.
Well, bang on time as well. An amazing presentation, hopefully a fascinating Q&A. It certainly was for me. Thank you so much.
Lovely to meet you.
Take care.